Hi there, dear students. It's very important for me to talk about um, the colligative properties chapter in the physical chemistry department, which is often very ignored, and most students don't know about it. But colligative properties, of a liquid, of a solution, are extremely, decisive in determining the vapor pressure, atmosphere, freezing point, melting point, boiling point, osmolarity, molality, and behavior. It's fluid solution behavior of the solution basically. And what is a colligative property? Colligative property, it's dictated by the number of solute particles dissolved in a solvent, and not the type of solute particles. That's the basic idea here, and it would affect all the dynamic properties and all the procedures that a solution can perform, whether it be electrolysis, electrochemical manipulation, whether it's freezing point, melting point, boiling point, vapor pressure, osmolarity, molarity, cohesion, adhesion, surface tension, capillary action capability. And on top of that, colligative properties is dictated by the number of solute particles in a solution. So solute plus solvent equals a dynamic equilibrium based solution. But then what so um, a solution can undergo active processes such as facilitated diffusion, reverse osmosis, active transport, receptor-based transport. It can also go through passive procedures such as diffusion, effusion, infusion, perfusion, and osmosis. So bear in mind, osmosis itself is a passive, down the concentration gradient process, but reverse osmosis is its opposite because it's facilitated. It requires energy input, and it's used in water purification techniques as well. Now, when colligative properties of a pure liquid are very, very different to a solution. And we basically use the colligative properties of pure liquids as control values for when they transform into a solution. Sucrose plus water, NaCl plus water, salts into water. It has a direct link to solubility as well, and temperature, vapor pressure, atmospheric pressure, freezing point, melting point, boiling point, elevation, freezing point, depression, melting point, anomaly, anomalous behavior of water, and all of these things become linked, and then now the rate of diffusion or osmosis of a pure liquid will be very, very different to the rate of diffusion and osmosis of a solution, particularly because of the number of solute particles dissolved in it. Technically, also the type of solute particles, but that's not what we investigate in colligative properties. That's not included. The type of particles are not included. It Colligative properties are it when you change the number of solute particles in a solvent, it has a direct impact on its surface tension, its ability of capillary action, adhesion, cohesion, van der Waals forces, intermolecular forces, intramolecular forces, hydrogen bonding, covalent. It has an impact across the spectrum of its interactions. And that's why colligative properties are very, very important, because although the calculation analysis is very, very simple, in grams per mole, grams per dm cubed, basic simple electrochemical analysis along the electroreactive activity series, but the theoretical qualitative impact is very much ignored, I see. And that's why remembering the importance of colligative properties in whilst studying physical chemistry topics such as reaction kinetics, solubility, molar calculations is very important. I hope you learned something today. Thank you very much for your time.